Now if you ask me to find the LCM of two numbers using prime factorization, I know what to do. But the question that remains in my mind is, do I truly understand what I'm doing to get the answer? Like I'm finding the prime factors, taking the maximum powers, multiplying them all together. Can I explain it in simple words to myself? It feels like there's something to understand here. And I know that the best way to understand anything is to really ask as many why and how questions that we can come up with, even if they sound like dumb questions, in fact, especially if they sound like dumb questions, and get to the bottom of what we're really trying to understand. So let's do that with LCM today. Let's try and look at the LCM with a new pair of eyes. So let's take two small numbers, say 12 and 18, and ask, if I have to find the LCM of these two numbers using prime factorization, what's step number 1 for us? The step number 1 is to go to 12 and ask, hey 12, what are your prime factors? And then go to 18 and ask, hey 18, what are your prime factors? Now I did that and they told me. 12 told me that it has 2 2s and 1 3, and 18 told me that it has 1 2 and 2 3s. Now is the time to stop and think about how to use this information to arrive at our LCM. And in a previous video, we did the same thing for the HCF, where we visualized in a diagram why thinking about prime factors makes it easier to find the HCF. That's not a strictly needed video, but you may find this video much more fun if you watch that video as well. So with that, let's jump in and ask how to find the LCM with this information that we have right now. And the first question to ask is, what is the LCM really? What is it? Isn't the LCM the first multiple of both 12 and 18? That's pretty much it, right? In other words, if I started the number line at 12 and keeps jumping size 12, and started 18 and keeps jumping size 18, at some point these two will have to meet. And the first place where they meet is what we call the LCM. So then, now that we know this, let's ask, what should the LCM be? The LCM just needs to contain enough factors of both 12 and 18 so that it's a multiple of both of them. Think about that. So what LCM does is goes to 12 and asks, hey 12, I'm trying to be your LCM. I'm auditioning to be your LCM, so what do I need? How many 2s do you have? And 12 says, oh, I have 2 2s. And LCM says, oh, okay, I definitely need 2 2s then. Only then will I be a multiple of yours. If I have only 1 2 or 0 2s, I can never be a multiple of you. Forget being a multiple of 18. So I have 2 2s now. How many 3s do you have? And 12 says, oh, I have 1 3. And LCM says, okay, cool. I'll have 1 3 as well. And then it asks 12, anything else? And 12 says, no, I have nothing else. So LCM is now happy. I've at least covered 12. And I don't yet know about 18, but I definitely know that I'm your multiple now. Let me go to 18 and find out. Then the LCM goes to 18 and asks, hey, what do you need? I'm trying to be your LCM. What do I need to have to be able to cover you? And 18 says, oh, me, I have 1 2. The LCM looks inside and says, that's great. I in fact have 2 2s. So no worries at all. I have an extra 2 even though you don't need it. And then LCM asks, what else do you need? And 18 says, I need 2 3s to be my multiple. If you have to be my multiple, you need 2 3s. At least. And the LCM says, oh, I have only 1 3 that 12 wanted me to have. Okay, I can add another 3. So now I have 2 3s as well. And the LCM asks 18, anything else? And LCM says, no 5s with me, no 7s, nothing else. So LCM is happy. The LCM says, now I have the exact minimum things that I need to have to be the LCM of 12 and 18. And if you find the answer to this, you will know what the LCM of these two numbers is, right? And you're guaranteed that this number will be a CM, which is a common multiple of both 12 and 18, because 2 into 2 into 3 is here already, that's 12, and 2 into 3 into 3 is here, that's 18. But what you also know is you have not included anything unnecessarily. So you know this will be your LCM, right? So 2 into 2 is 4, into 3 into 3 is 9, so 36 is your LCM. Now let's visualize this in a different way. Now the way I like to do it is to imagine 12 to be a circle like this, containing its prime factors, and 18 as well, like this. Now, how is the LCM connected in this picture? How should you think of finding the LCM using this picture? If I were to do it, what I'll do is that, hey, I'm still the LCM. I'll go ask 12, what are your factors? I need to be your multiple first if I have to be a multiple of both of you. I first need to be at least your multiple, and I could have picked 12 or 18 first. I'm just picking 12 first. So 12 LCM says, okay, I need to contain everything that you contain. So 2 into 2 into 3. That will make me your multiple. Great. Now I have another job. I also need to be the multiple of 18. So I'll go to 18 and ask, what do you need? and 18 says I need 2 into 3 into 3. But before adding these also to the LCM bucket, the LCM realizes, wait, it's possible that some things that you need 18 were already covered by 12. So I have to ask 12 and you, what's common between the two of you? Because whatever is common, I've already covered. So that's what the LCM does. It wants to find out what's common. And the way to do that is to just observe what's common between the two. You'll notice that there's 1, 2 and 1, 3 that's common. And because that's the case, this 2, 3 that you see for 18 has already been covered by becoming a multiple of 12. And that's beautiful if you think about it. That part is already covered. So LCM just needs to cover this extra 3 and 18 will also be covered. It doesn't have to cover those 2 and 3 again because it was covered for 12. Now in that way, when you look at it, the LCM is simply this 2 multiplied by the 2 into 3 that's common, which you see over here, multiplied by the 3 that's not common between 12 and 18. There's an extra 3 in 18 that's not covered if you become a multiple of 12. So you only need to multiply that. And now I have a question. And the question is, can you look at this diagram and also figure out what the HCF is? Notice that just by drawing the building blocks of 12 and the building blocks of 18 and bringing them together so that the 2 and 3 of 18 and the 2 and 3 of 12, in this case those are the common factors, bringing them together like this gives us both the HCF and the LCM in one diagram beautifully. Because once you've done this, the HCF is simply the common factors multiplied with each other. We went really deep into this in the previous video. So 3 into 2 will be the HCF, which is 6. And whatever is visible once you do this, multiplied together will be your LCM. 2 into 2 into 3, which is over here, into 3. And now you also know why this is true. I find this really beautiful. Let's do one more example to really understand this even better. So let's take all of these out. And let's take our two new numbers, 120 and 84, just like we did for HCF. And pause right now. And think about find the prime factors of 120, draw a diagram for it, prime factors of 84, draw the diagram for it, observe what's common, and notice that when you merge them, whatever you can see multiplied together will be your LCM. I'm going to do it right now. For 120, I have 3 2s and 1 3 and 1 5. So I have 2 cubed. 3 2s, the short form of writing that is 2 cubed, right? Into 3 into 5. And for 84, I have 2 2s, 1 3 and 1 7 equals 2 2s, 1, which is 2 square into 3 into 7. Now finding the LCM simply becomes including all the things already included in one number. So if I write the LCM out over here, the LCM, that will simply be equal to 2 cubed into 3 into 5, which is basically just all the numbers that 120 needs. 2 cubed into 3 into 5. And then all the things that 84 needs that were not already covered by 120. And to find that, we just find what's common and merge the diagram. What's part of 84 that's already covered? 2 2s and 1 3. So that's already covered, which means the only thing left to be covered is another 7. So you multiply by that 7 as well, and then you have your LCM. So let's find out what the LCM is. It's 7 5s are 35, into 3 is 105, 105 into 8. That's 840. 840. I hope that's correct. So the LCM is all the things that are visible once you merge it, so that you're not counting the common factors twice because you don't need to. Now if you remember, the HCF is actually also available in this diagram directly for us. The HCF is just all these multiplied together, which is 2 into 2 into 3, which is 12. So you have everything that we need. And now is a good time to pause and ask, hey, how is this diagram and this way of thinking about it connected to the methods that I'm already used to? Now one of the methods I was used to was writing the LCM as looking at each of the prime factors, say 2 first, and noticing what's the maximum power. And then I'll write that. So the maximum power in this case is 2 cubed. And then go to the next one, 3. 3 power 1 here, 3 power 1 here, so into 3. 5 power 1 here, no 5 here, that can be taken as 5 power 0, so taking 5 power 1. And then no 7, nothing else over here, but there's 1 7 here and no 7 here, so taking the maximum power of that, which is 1 7. Notice it's exactly the same thing that you've done here. And the reason you're taking the maximum power is that if one person needs 3 2s and the other person needs only 2, By taking the maximum, you're ensuring that everybody will be happy, even if there are more and more numbers. As long as you've taken the maximum power of a prime factor, you know everybody else will be satisfied. So it makes sense to do this. There's another method you may have been used to, which is this way of writing things, like draw a line, write it, draw a line, keep going. Have you done this? So if you have, then what you're doing is actually first finding whatever is common. 2 into 2 into 3, because you keep dividing by both the numbers. And if you stop right here, you get the HCF. 2 into 2 into 3, right? And then what you start doing, if you're finding the LCM, is that you start looking at whatever is divisible by even one number. So this in this case is 2 only goes in 10, so you write that. And then you keep finding out whatever is not common. So till here is your what I can call your common part, after which begins your not common part. And observe how that neatly ties into this diagram. 2 into 2 into 3 is over here. You multiply that alone, you get your HCF. There's 2 into 5 that's left behind on the 120 side, and there's another 7 that is left behind on the 84 side. And you multiply all of these together. You were told that you'll find the LCM, but now you know exactly why.